Question, we've got two ropes attached to a central point, which I'll just put a little dot on. And both these ropes are holding up a hanging mass, and the mass happens to be 50 kilograms. So the tensions in these two ropes and the force of gravity all converge to this spot right in the middle. So I'm going to make that my free body diagram. Ropes always pull. So I've got T1 pulling it to the upper right, already labeled. And from that point, I'll label it T2. It's pulling it to the upper left. And then we've also got pulling down my force of gravity. So I've got three vectors simultaneously acting at that little point in the middle where they all converge. Now the object is not moving, and because it's not moving, we should recognize that the net force has to be zero, which means that the sum of all the forces acting on the object, since that's the definition of net force, has to equal zero. So when I add up these three vectors tip to tail, that's how we sum vectors, they have to make a closed triangle with no gap. If there was a gap at the end, that would mean there was a net force. So let's do that. We'll do it right below. I've got T2 pulling it to the upper left. Now tip to tail. At the tip of T2, I'm going to start the tail of T1. T1 is pulling it to the upper right. Now I haven't put an arrowhead on it yet. When I finish drawing T1, at the tip of T1, I'm going to start the tail of FG. Now if I stop my diagram here, you can see FG will be down at an angle. We know the force of gravity has to be straight down. So I'm going to make sure that this T1 is drawn so that the tip of T1 is directly over where I started the original diagram, where I started T2. So now at the tip of T1, I can finish my picture. FG is straight down like that. So there's my diagram. Now we can quickly get the value of FG. It's just m times g, which is 50 times 9.8, which is 490 newtons. So we know one side of it, 490 newtons. Now we also know some angles. If we know this angle at the top is 40 degrees with the ceiling, and I draw a horizontal line down the middle so that it's parallel to the ceiling. Alternate interior angles tells us that if this is 40, then this angle right here is 40, and this angle right here is also 40. So all these angles are identical to each other. They're all 40 degrees in this case. So let's label this on our picture below. T2, this little angle right here, is 40 degrees. Now, if FG is straight down, because we're worried about angles inside the triangle, because we need those to use the trig method. If FG is straight down, that means it makes 90 degrees with this little blue dotted line. So that means this angle right here would have to be 50 degrees, because 50 and 40 add to 90. Similarly on the top, T1, we can see from the picture, makes an angle of 40 degrees right in here, which means once again, because FG is straight down, that's going to be 50 degrees. Now the other angle, we can work out a couple of ways. One is to say, okay, that's 40 degrees because of that alternate interior or Z rule. So that's 40 degrees right here. Similarly, this is also 40 degrees as identified above. There's 40 degrees right there. Add them up together and I get 80 degrees. So let's do that. We know that all of that adds to 80 degrees. Now the other way I could have done this, I know that both those are 50 and the angles inside a triangle must add to 180. So 50 and 50 is 100, so that must be the remaining angle of 80 degrees. Now we're trying to solve for T1. I've got a whole bunch of angles. I know every angle and I know its side. So I'm going to use the sine law. Now I'm trying to find T1, so I'm going to put that as my unknown on the top. T1 divided by the sine of the angle opposite to it. So here's T1, the angle opposite is 50 degrees. So T1 over sine 50 equals, now here's my known vector. So I got to make sure that's in my equation, equals FG divided by the sine of the angle opposite to FG, and opposite to that is 80 degrees. Now if I want to solve for T1, I multiply both sides by sine 50. And when I crank that out in my calculator, you get your answer to be 381 newtons. Now you could do the same thing for T2, but notice there's some symmetry in the triangle. I've got two angles here that are 50 degrees, so it's an isosceles triangle, we say. So T2 would be the same. It would also be 381 newtons, and that's a predictable result based on the symmetry of the question above.